One thing I'm going to do before I proceed further with this script is I want to save the script. So I'm going to click on save and save the script, give it a descriptive file name, not just untitled or the date, but like what are we doing? So this is notes and I'll call this built-in functions. You can call it something else if you want, but that's what I will call it. And I'm going to keep working on a series of videos all using this script, and then I'll make this script available on our course website when I'm finished. So let's start a new cell, and I will call this nesting functions. Nesting functions means putting a function inside of another function. So this is pretty simple to do with MATLAB. If I start with a variable like x equals 2, and I don't need to see that reported, you can suppress that output. Let's do g equals square root sine of x. So the first thing that's going to happen, this is just like in algebra, the inside function gets evaluated first, and then the answer to that will be put into the square root function. So let's go ahead and run section and see what we get with that. We get a nice decimal number. Cool. This can be hard to read though. So I'll say nesting functions can make it difficult to follow. For clear and elegant code, use an intermediate variable instead. I'll put that in the notes. So instead of doing what we did, let me comment that out. Comment out because I don't want to run that anymore. I'm going to do this a different way. Say we're going to start with the same thing, x equals 2, but instead of doing the square root and the sine all in one line, we're going to do it in two. And maybe I'll call it intermediate variable or just interm for intermediate variable and say let that be equal to the sine of x. And I don't want to see the output because this is an intermediate variable that I don't care about. What I really care about is g, which is going to be the square root of that intermediate variable. Don't suppress this output because this is what I want to see on the screen. Now when I run section, I'm going to get the same thing. It's hard to see that, but I did get it twice. I did get it again in my command window. And now I have an intermediate variable that I can use again if needed. Let's take a moment to talk about how to use help. So using the help features. The one way to do that is to use the word help actually in the command window. Actually, let's keep going in the script. So we can use the command help will tell us about a function. When you're not sure, hey, is tangent the one that is in variable in degrees or in radians? So I'm going to say help tan, and I'll just run this section to execute that command real quick. Let me move this up. We see some information about the function. It's the tangent of whatever you put in. That's what argument means, input, in radians. So the argument, the input, has to be in radians for this function. And then there's also some handy links to inverse tangent, tangent in degrees, and I don't know what this one is. I think it's two-dimensional. I could click on it and read about it. Another way to get help is doc. So this is the help command gives us just a quick how to use this function, but it doesn't tell us a lot about what tangent is. So let's instead do doc tan. See if I can suppress that output and run this section. So now doc gives me this whole new window. Let me move this down a little bit. I get a whole window that says, okay, tangent, and it's telling me a little bit more about it and some examples that I can minimize and look at if I want to. So that's a nice way to get help if you need more details than what you get with help. All right, let's do a couple more things while we're here. Let's start a new cell, call it roots and exponents. Roots and exponents. And let's see, let's do absolute value first of all. That's just abs. So I'm going to run this section and see what I get. Of course, I get a 3. That's the absolute value of -3. Another fun one is nth root of 6. Now, what is the second variable? Notice when I pause here, I get this pop-up that tells me you need to give me two numbers. First, what do you want to take the root of? That's the x. And secondly, which root do you want to take? We've already seen square root, but this will allow me to do a cube root, for example, by putting in n equals 3. So let's suppress that one. I don't need to see that and see What is the cube root of 6? Well, it's about 1.8. Let's try another one. Nth root of 6, but 1/2. So I'm going to suppress the previous one. We've already seen that. What's a half exponent? Do you remember? Well, this isn't a half exponent, so a bit of a tricky question. Remember, square root is a half exponent, but this is the root. So I'm taking the 1/2 root. What do you think we'll get when we take the 1/2 root? That's the same as squaring. So we get 36 here, and we can change that to see that it is indeed squaring by trying a different input. And a couple more. Let's get some exponents in here. EXP is another one. EXP 10. Let me make a note here. Half root, this squares the number. I'll just say this squares it. EXP is the how we get to the transcendental number e. So if you want e to a power, EXP is one way to get there. EXP 10 is the same as e to the 10th. So you can check this by using your handheld calculator, graphing calculator, or something if you want. But that's what EXP is. E to the 10th. Okay. Let me say this one. If you do e to the 10th like this, that won't work. So let's suppress all that and see what happens when I type in e to the 10th. Notice I'm not putting this one in the script. I'm just putting it in the command window real quick because I know I'm going to get an error. Undefined function or variable e. It does not store the number e like it does with pi. So if you want e, use EXP. All right, one more while we're here. Let's do log. Log is the, the logarithm. But which logarithm? Let's see what happens if I do log of the exponent of 10. Exponent, remember, is e to the 10th. So let's run this, run section, and see what we get. We get 10 because log is MATLAB's way of taking the natural log. This is how mathematicians use log. It means natural log. We don't use ln. Sorry. If you're not sure, if you forget, you can always do help log and say, which log is this? Natural logarithm. So you need to know if you want log base 10. Well, here you go. Log base 10, I think, is what it is. So this is what mathematicians call the common log. All right, that's enough for this one. We'll pick up in another video.